So in this lesson, we're going to look at hypothesis testing. At least I'm going to introduce the idea of hypothesis testing. First of all, what is a hypothesis? In statistics, it's a statement about a population measure, otherwise known as a parameter. For example, the population mean, standard deviation, and population variance are all considered parameters. All right, and so a hypothesis is a statement about these population figures. Now, hypothesis testing is a procedure used to determine whether the hypothesis should be rejected based on sample data. So we take sample data and we use that to determine whether or not we should believe a statement about our population or reject the statement. Now, in terms of hypotheses, when we do a hypothesis testing question, we always have two hypotheses. The null hypothesis is the statement about the population parameter in question, what you believe is going to be true unless you have evidence that contradicts your belief. The null hypothesis will always contain the equal sign, and that's important. Now, by equal sign, we have situations where it's strictly equal to, less than or equal to, or greater than or equal to. But in all these cases, the equal sign is included. The alternative hypothesis is the opposite of the null hypothesis. So with that said, why don't we just look at an example, and we'll use this notation to show how this comes together. So you read a question, and the question might state the mean income of females is less than the mean income of males. So this is what you might read in the question, and when it comes to putting the hypotheses together, we can say in this case the mean income of females is greater than the mean income of males, and we always include the equality in the null hypothesis. Okay, the mean income of females is less than or equal to, so that puts it in the null hypothesis. We'll do many examples as we progress, but that's just to clarify that the null hypothesis will have that equal sign included in its statement. Now, when it comes to dealing with hypothesis testing, there's two types of errors that we can make. And they are, type 1 error is rejecting H0, the null hypothesis, when it should be accepted. And the flip side is not rejecting H0 when it should be rejected. Okay, now to show this, I've got an example, to a parallel example. So in case of the result of a trial, suppose our statement is true that the person in question is innocent, and yet they are convicted. In this case here, we've got an error that was made. Suppose they're not innocent, in other words, they're guilty and they are convicted, then this is correct. If the person is innocent and they are acquitted, that's correct as well. And if the person is not innocent or guilty and they're acquitted, we know that another error was made. So in terms of the results of H naught, these errors are both the type 1 and type 2. When we know H naught is true and yet we rejected it, that's a type 1 error. And this would be a type 2 error. Now, we are going to keep in mind the probability of making a type 1 error when we're dealing with hypothesis testing. Okay, so you're going to see at the level of significance of alpha. Alpha represents the probability of making a type 1 error, rejecting H naught when it should, in fact, not be rejected or should be accepted. Next, let's talk about this idea of one tail versus two tail. So the process is always going to be the same. Suppose we had a situation where we had a two-tail graph, and this shouldn't be new to you, but what does that really mean? It means that we have two tails in our normal curve. One tail means that either the tail is on the left-hand side or the tail is on the right-hand side. All right. And so this is your left tail and right tail. I also want to mention that there is a special value. So depending on the situation, if we have large sample size, we're going to be looking for the values. They're called critical values. I'll explain that more in depth. The values that cut this off, I look at the critical value as a fence. You're either on this side of the fence or you're on this side of the fence. Likewise here, you're either on this side of the fence or you're on that side of the fence. If it's a small sample size, then we're going to be dealing with T. So once again, Z or T, Z or T. So these form these fences, and you're, like I said, either on one side of that fence or the other. Now, keeping this in mind, how does this relate to the hypothesis test? Okay, so in our first example, we have the mean pulse rate is 82 beats per minute. So in this case here, if we put our hypotheses together, in this question, it's saying that the mean is equal to 82 beats per minute, or the mean is not equal to 82 beats per minute. So what does this do for us in terms of the type of hypothesis test we're dealing with? Well, this actually implies a two-tail situation. So when we have equality, it's a two-tail situation. In the second case, the mean life expectancy is greater than 36 days. In this case here, we can say then that the mean is greater than, so if it's greater than, we always show the value with the alternative hypothesis is greater than 36 days. And with the null hypothesis, we include the equality sign. So that would be the opposite and equal. So in this case here, this actually determines which direction the tail is in. So it's greater than, this is going to imply a right tail. All right, so if we were to draw the graph or the curve, it would be a right tail. Likewise up here, this curve, as mentioned, is two tails. So we can go straight to those pictures. And then we have to find these critical values, which you'll be shown how to do so. So what's important is we have that. Now, suppose for the sake of argument that the mean life expectancy is less than 36 days. Well, that would make this value less than, and so it would then become a left tail situation. All right, so just make sure you pay special attention to the wording, okay? And that tells you what the direction is going to be for the question. Now, some other jargon is what's involved with hypothesis testing? Well, here are the 5 steps that are going to be taking place. First, state the hypotheses. Second, find the critical values. In other words, find the Z value or T for small sample size. Remember, sample size n less than 30 means we use a T value. Then we're going to compute the test value. And by test value, it is just the Z score. So we know how to do that. Then we're going to make a decision. We either reject H0 or do not reject. And then we're going to state our conclusion. And when we state our conclusion, we base it on the alternative that we have written. And then next, critical region and non-critical region. Well, the critical region is the, or otherwise known as the rejection region. And that's the area that indicates to reject the null hypothesis. The non-critical region is the area that indicates do not reject the null hypothesis. And the critical value, that's the dividing point between the rejection region. Actually, we can say between the critical region and the non-critical. Both would work. Regions. Now, when we look at our pictures up here, so we have our different scenarios. This is a rejection region. So if our test score falls in this area, we reject, as well as here. And in this case, we do not reject H0 in this area here. Okay, so do not reject. Do not reject in this area, but you reject in the tail. Do not reject anywhere here. And then we would reject here. These are the critical values that we look for that divide our graph into rejection region and non-rejection region. So critical region, non-critical, critical, critical, non-critical, non-critical, critical, depending on the scenario. This will all come together when you try the problems out. You'll see that it's pretty straightforward. As long as you follow the 5 steps, you'll see that it is very systematic and it will all come together.